I'm happy that I'm part of IEEE Sensor Conference. I'm Fatemeh Nikbakhtnasrabadi from Glasgow University. We are working on bendable electronic and sensing technology. Actually, we are an interdisciplinary group. We are working on robotic skin and sensing application for environmental monitoring and healthcare application. The outline of this work is I will speak about the motivation of our work, the experiment we did, and the result of our experiment. Then I will explain about our future plan, because recently we started that project and we are in the first step of our work. Okay, why we need water quality monitoring? As everybody knows, water has a very important effect on our life, and it has very important effects on quality of our life in terms of agricultural application and aquacultural application. For example, in aquacultural application, for fish production, we need water with pH from 6.5 to 8.5, and we need to monitor the water very well. Traditional method that they are using for monitoring, it's not sufficient, because they can get just some sample from some part of water, and it doesn't show the clear picture of the quality of water. There are lots of parameters in water that it's very important to monitor. For example, pH, dissolved oxygen and conductivity, and temperature. And I think more than 100 parameters there are in waters that we should monitor them. So for providing the multi-sensor network for water quality, we need to provide energy for that application. We try to use our supercapacitor that we developed it before to provide energy for our system. Previously, they use batteries for charging the system, but batteries are not sufficient for this application, because the lifetime is not enough, and they provide contamination for water. But our supercapacitor that can use for high flexibility application, and they are very environmental friendly. Okay. This is this shows the construction of our work. We start from providing material for our advanced sensing system. First, we provide some paste for our sensors. For conductivity sensor, we prepared a rhodium oxide paste, and for a temperature sensor, we provide a graphite polymer composite. The technology we used for preparation of sensors was screen printing. Previously, we also present our work about pH sensor, and we have planned to use our multi-sensor in one system. Then for energy system, we used commercial solar system integrated with our supercapacitor to charge the system for all the day. To analyze our system, We test the electrochemical application of our work and how our solar cell is working. We test the solar cell application, and we change the temperature from 25 to 55 centigrade gradually. And for conductivity sensor, we change the conductivity from 10 to 11,000 microsiemens per centimeter. The reason we use that range is because the conductivity of river water and the tap water are in this range. You can see from this picture the setup we provide for monitoring our sensor. This is the commercial solar system that we use, and this is our supercapacitor, and that one is conductivity sensor and temperature sensor. For conductivity sensor, we use two electrode, ruthenium oxide thick film electrode, and we put it on solution, and we increase the NaCl to water to change the resistance of the water, or sample, I mean. And from this equation, we calculate the conductivity of our cell. K represents the cell constant, which is which can say it from the distance between two electrodes and the area of sensors. As I said before, we measured conductivity from range 10 to 80, and from 100 to 11,000 microsiemens per centimeter for river water quality. For temperature sensor, we provide interdigitated graphite thick film electrode, and we put it in our solution and change the temperature gradually from 25 to 55 centigrade. From the slope of this graph, you can see the sensitivity of the sensor is 0.28 ohm per degree. And here we can see the constant operation of our sensor during the time. After using power for sensor, we removed the power from our sensor, and we installed the solar cell and supercapacitor to charge sensors. First picture shows how our supercapacitor work, and from second picture you can see the constant ability of our sensor to work with hybridization of solar cell and supercapacitor. So we provide two pastes for temperature sensor and conductivity sensor, and we operate the variety range of temperature and conductivity. Then we used hybrid integration of solar cell and flexible supercapacitor to operate the system. Our future plan is to use multi-sensor for measurement of pH, dissolved oxygen, nitrogen, and turbidity of water. Because our supercapacitor have high energy, it provides high energy, we need some low power electronic circuit to divide energy between all sensor. And for online monitoring, we need to develop our work to have some receiver and transmitter for online monitoring. Then we will work on packaging and deployment of our multiple sensor. And I would like to thanks our funder from EPSRC that provide us this opportunity to develop that work. Thank you very much.